really excited to introduce our next speaker. His name is Valentin Deleplace. He's a senior developer for backends, databases, and cloud architecture, platform, and algorithms over at Google. Today, he's going to be talking about the many choices that we have when it comes to GCP, and more specifically around Go Web App serverless options in GCP. Valentin, I think you could go ahead and unmute yourself and start your video. You should be good to go.
Hey, Wilkel, Angelica, would you say the sound is good on my part or pretty poor?
Yes, I can hear what you're saying. I feel like it's good.
Okay, this is the web client and I don't trust it, but we will proceed anyway.
Give it a go. You never know until you try.
Awesome.
Yep. So I will share my screen. This one should be good.
Awesome. You can see it.
You can see my screen. Great.
Yes.
So I will just start presenting. Hi, my name is Valentin. Today I'm here to talk about Go and serverless in Google Cloud. But first, a few words about myself. I used to be a Java developer, building mostly web backends. Then around 2012, I discovered App Engine and the Go language, and then the Go runtime available in App Engine. This was refreshingly different from what I knew about web development and hosting. I loved it. That's when I knew that I wanted to work in serverless environments, long before the word serverless was used in that context. Google Cloud is what we call a public cloud. Today, I'm talking only about technologies and products available in Google Cloud, although, of course, some of the concepts exist in other cloud vendors as well. Google Cloud offers many services to consumers and businesses. The umbrella name Google Cloud actually covers two distinct worlds. On the right, we have Google Workspace, formerly known as G Suite and formerly known as Google Apps for Work. It's a family of productivity and collaboration tools to do email, spreadsheets, etc. On the left, we have GCP for Google Cloud Platform, a suite of computing services for business customers. All of the serverless computing products are on the left side. They are part of GCP. There are a few distinct acceptations of the word serverless. Today, I'm referring to these three specific services, all of which allow you to deploy some Go code to handle incoming HTTP requests. App Engine was the very first compute product in GCP, released in 2008. Cloud Functions and Cloud Run came much later. My boss, Greg Wilson, has written a handy list called Google Cloud Products in 4 words or less, from which I took these extremely short definitions. App Engine is a managed app platform, mostly used to build dynamic website backends. Cloud Functions is functions as a service. It lets you specify the code to be executed in response to an event, which can be an HTTPS request, but there exist other kinds of triggers as well. For example, do something asynchronously when a new file has freshly been copied to a cloud storage bucket. Cloud Run is a serverless platform for stateless containers. It's perfect for any application that can be expressed in terms of a HTTP server inside a container. Serverless platforms have a lot of nice properties. They scale automatically to serve thousands of concurrent users if you happen to have a sudden traffic spike. They also scale down to 0 instances, which means that I don't have to pay anything when there is no traffic. I pay only for the resources that are actually in use at any given time. But my favorite thing about these platforms is that they are managed. They are managed by the cloud vendor, not by myself. This means in practice that I never have to worry about the underlying hardware infrastructure, network configuration, and OS security patches. I prefer to focus on my app. When you go serverless, you need to design your app carefully in a stateless way. This means that the specific server instance that processes a given request does not hold data and is not regarded as a source of truth. This is a fundamental property of auto-scaled serverless architectures. The user data, if any, lives in distinct stateful components, which can be a database or a file storage or a distributed memory cache. Basically, this is the kind of things we want to deploy, a web server written in Go. This code says two things. First, register an HTTP handler function. This one is just a hello world. And two, listen to a port, by default the port 8080. Serverless is a misnomer. Of course, there are servers. I prefer the term serviceful because the managed infrastructure provides a simplified access to a wide range of cloud components that don't live inside the serverless instances, which are here. We want to programmatically use these services here from our Go web app here. To achieve this, it would be awesome to have a ready-to-use Go client library for them. Good news, they all come with high-quality client libraries for Go and for several other popular languages as well. Sometimes a third-party popular library does the job. For example, any MySQL connector module is fine to connect to a Cloud SQL database with MySQL flavor. And any Redis client is fine to connect to memory store with Redis flavor. As an illustration, I wrote and deployed 3 versions of a simple app called Hotmail, designed to transfer a file from a computer to a mobile device. First, we drag and drop the file from the hard drive to the Hotmail web page, for example, a photo of a kangaroo. The file is uploaded to the cloud. The web page now displays a QR code, which encodes a temporary public URL to access the file from the cloud. So when the user scans the QR code, they get the kangaroo. I'll do a quick demo. In my file explorer here, I should have the photo of a kangaroo. I have the Hotmail web app in my web browser here. So what I can do is to drag and drop the kangaroo. There should pop up a QR code. So now I will scan it with my smartphone. Okay, looks good. Yes, I did get the kangaroo. It worked. Very cool. Let's deploy Hotmail to App Engine. So do I have a command line here? So I already have the gcloud command line tool installed and configured with my account and my current project. This is my account and this is my current project, Hotmail. I will just run gcloud app deploy. And I'm deploying to a new version of the app. Oh, never mind. I will stop that and add the command time just to see how long it will take. Okay. So I'm deploying to a new version of the app, which will handle 100% of the traffic. My previous versions still exist and are still deployed, but they don't serve traffic anymore at the main app URL. I should have the Google Cloud platform web console here somewhere. Okay, so here are the versions deployed for Hotmail, and the version that has all the traffic is called B1 here, and I'm deploying a new one with that has the name, the date of today. Okay, that shouldn't take very long, hopefully. The code structure of my app looks like this. It's a standard Go web server, which contains both the static assets and the dynamic handlers. And I have an executable here, main, in a subfolder of CMD. This is all very standard in Go. Still uploading, okay. Because it's a standard Go web server, I can build it and test it locally. I could also decide to host it somewhere else without changing the code, as long as I'm not using any proprietary services. This specific version of Hotmail uses the proprietary service cloud storage, so right now it's meant to run inside GCP. Here is again the command line to deploy from the source code. It's really simple and it's great. Let's see if it's finished. Yes, it took 1 minute 30 to deploy, and I can visit the app at this URL, app browse. Okay. Okay, maybe I shouldn't have done that. Never mind. At least it's deployed. Okay. Now let's deploy Hotmail to Cloud Functions. Cloud Functions is not exactly a website hosting option. We are deploying all the dynamic handlers to Cloud Functions, and for the static assets, HTML, JS, CSS resources, we will deploy to Firebase hosting. The command to deploy one function looks like this. gcloud functions deploy, then the name of the function, and then a few parameters. Here I'm deploying only one function. They all must be deployed separately, and I happen to have 3 functions in my project. If I want to redeploy the static assets, I will launch Firebase deploy. Oh, I forgot to ask how long it takes with time. Sorry about that. I think redeploying the static assets with Firebase is pretty fast, like 10 or 15 seconds. Yes, 8 seconds only. And it's a little bit longer to deploy one function. It says here up to 2 minutes. So typically between 1 or 2 minutes to deploy one function. As I mentioned, this command line for gcloud function must be launched as many times as I have functions, but only once for Firebase deploy. 2 other talks today will cover cloud functions, one by Frederic and one by Misha. So I won't be talking anymore about cloud functions. Please stay tuned. Now we'll deploy to Cloud Run. Cloud Run is an amazing piece of technology released 2 years ago. With Cloud Run, you have the freedom of infrastructure as a service and all the advantages of serverless at the same time. With Cloud Run, your code is a regular Go web server, just like with App Engine. Typically, you would test locally in a container with Docker. Deploying to Cloud Run normally involves 2 steps. First, you push an image revision to a container registry or artifact registry. This can take about 2 minutes. And second, you ask Cloud Run to deploy this specific image. This last step is fast, usually 20 seconds only. So I'll do it right now. Yes, I forgot to mention that in order to build a container, okay, Cloud Function has finished deploying. That's cool. In order to deploy a container, first I should build the container, but first I should build my Go application, because I will deploy a binary actually. I'm not deploying from source right now. So here I'm building my server. Then I will build my Docker image locally. Okay, success. And then I will submit, so deploy this build to container registry. I will kill it and ask how long it takes. Time gcloud builds, submit. So as I mentioned, this part is the longest one of the deployment process. It can take 1 or 2 minutes. Okay. So these are the commands that, okay, those are the 2 commands, one to build the Go web server and one to build the Docker image locally. And those are the 2 commands, one to deploy to container registry and one to deploy to Cloud Run. I shouldn't have shown that, but actually, it's been a few weeks that then we can now do all of this in one single command, which is still in beta, that allows us to deploy from source. So with only one command that will take 2 to 3 minutes, I can deploy my Go web server from the Go files without having to specify anything extra to build the web server, build the Docker image, publish, so push the Docker image and deploy the Docker image to Cloud Run. I tried it, it worked, and it was amazing. So a word about staging in all of the serverless options in Google Cloud. Staging is very important. It's about deploying the app for testing, Q&A, or doing experiments, but not to production. So it's possible with all of these products to deploy to different versions of the app or of the function. And some of the service dependencies like memory store or data store, etc., some do offer some kind of multi-tenancy, which means isolating data with namespacing, etc. But in my opinion, it's too easy to shoot self in the foot. So my advice is this: you'd better use a distinct isolated GCP project for staging. This is the most straightforward and safe way to achieve isolation from production. Just my advice. Concurrency. All of the options discussed today have the ability to spin many instances handling requests concurrently. Each Cloud Function instance is able to handle only one concurrent request, so you have to keep them in mind. On the other hand, each App Engine and Cloud Run instance may handle many requests concurrently without starting extra instances. The max concurrency in Cloud Run is 80 by default and can be configured up to 250, I think. This is a really important feature because a typical handler spends very little time using the CPU and much more time waiting for the database result or other cloud services. So even during a request processing, it still spends a lot of time idle, which is a good opportunity to let other requests use some CPU and launch their own database queries and service calls. Now a word about security. With App Engine and Cloud Function, you basically deploy from code. And in Cloud Function, you can even type your code directly in the web console. Do I have this here? So this is the list of the functions, of the free functions that are deployed in my project in the Cloud Function case. And if I look specifically at one of them, I can see the details when it was deployed, and I can even see the source. All the source files involved are available in the web console. So for App Engine and Cloud Function, we deploy from code, which means that we don't specify much in terms of operating system, runtime environment, etc. Which means that we don't have to worry a lot about patching the operating system and the runtime. And so in case of new discovered vulnerabilities, we only have to care about our own code and the specific dependency versions, the Go modules or Go package versions that are our dependency. If we need to bump a package for security reason, then it's on us, the cloud practitioner, the customer, to fix it and redeploy. For Cloud Run, it is much more powerful. I mean, you can do many things in a container, and that's amazing. But it also means that you have to take care of the security patches of the image base, of your base image, and all of the binary dependencies that you might happen to depend on. So consider deploying often, at least for security reasons. Now a word about cold start. A cold start or loading latency happens when a specific request has a higher response time because it's waiting for an instance to start. This problem, in my experience, is specific to serverless platforms. So it's good to keep in mind that when scaling up from 0 to 1, obviously one instance needs to be started, and it's usually fast to spin an instance with a basic Hello World server in App Engine or Cloud Run. It can take less than 1 second. But if your app happens to have a lot of dependencies and initialization, like let's say 15 seconds of initialization, then sometimes the end user will have to wait for 15 seconds before getting the response, the HTTP response. That is not fun. It is a serious problem. There are many ways to mitigate this problem, and I encourage you to explore them if you decide to go serverless. To conclude, we've seen that the 3 main serverless compute options in GCP work very well with the Go language. Cloud Run is like an evolution of the original App Engine, with most limitations lifted. Basically, inside a container, you're free to do whatever you want. The ability to include on any arbitrary binary dependency is extremely powerful. For example, in my previous job before Google, we needed to parse 3D files from SketchUp. The only effective way to achieve this was to use the official SketchUp SDK, which happened to be a Windows DLL. So at first, we used a fleet of Windows servers just for that purpose, which was not super convenient. Then we successfully used the utility called Wine to execute, it's an emulator, a Windows emulator for Linux, to execute the DLL from a Linux machine on Google Compute Engine. So now we had a fleet of Linux servers to manage, and it still involved quite some toil. Nowadays, this kind of workflow is possible easily in a serverless way with Cloud Run. Wrap the Linux distribution and the DLL and Wine and the Go web server inside a container, and you're done. And this is truly amazing, in my opinion. That's it for today. Thank you very much for listening. If we still have time for questions, then I'd be happy to take them.
All right, Valentin, thank you so much. Such an awesome presentation. Thank you. I hear a lot about Cloud Run when I work on the Packer team, and we get a lot of issues that come through the wire for Cloud Run. So it's really nice to kind of get some background on it and learn a little more. So thank you for that.